Okay. Today we're going to go over chapter 7.6. Alright, we skipped 7.5, we're going to go 7.6, but I'm going to cover both of them, 7.5 and 7.6, because they're very closely related. Alright? So, what we're going to talk about today are some things that we call trig functions. There are three trig functions that we're going to talk about. Right? We call them sine, cosine, and tangent. All right? If you look on your calculator, whether you have a graphing calculator or a calculator like this, you'll see that you have these three buttons, SIN, COS, and TAN. Okay? Those stand for sine, cosine, and tangent. All right? Okay, so for most of what we're going to do today, we won't be using the calculator yet. Okay, but we will at the end. I'll let you know. All right, so let's talk about what sine, cosine, and tangent are. Let's draw a triangle. Okay? And we're going to just use sine, cosine, and tangent with right triangles. Okay, so we've got this right triangle here. We're going to label it A, B, and C. Okay? Now, what sine, cosine, and tangent are is they are ratios of these different sides of our triangle. Okay? Once we do some examples, it's going to start making more sense. So, you need to know one of these two different little mnemonic devices. Okay? I'll teach you one that I use, and then teach you another one that a lot of people use. Okay? One that I use is called, I say, Oscar had a heap of apples. Right? Oscar had a heap of apples. And what that stands for is these first two make up our sine function. These second two make up our cosine function. And our last two make up our tangent function. And we'll talk about what these letters mean. Okay? So, let's take sine, for example. Okay? I want to take the sine of one of my angles. Now, we won't ever take sine, cosine, and tangent of this angle because we know that this is the right angle. We know it's 90 degrees, so we don't have to mess with that. But we can take sine, cosine, and tangent of A or C, okay, the other two angles in our right triangle. Right? Now, when we use our trig function, we're always going to say sine of, and what comes next, whatever we put in that place right there, that is our angle. Right? The angle always goes next to either sine, cosine, or tangent, whichever one we're using. Okay? Now, let's talk about what these letters mean. Okay? And that'll tell us what comes next. If I look at angle A, right, I'm looking at angle A, there are three sides. I have three sides in this triangle in relationship to angle A. I have the opposite side, the adjacent side, and the hypotenuse. Okay? So when we look at angle A, right, which side would be the opposite side of angle A? Well, the opposite side would have to be side BC, okay, because it's on the opposite side of the angle. The second side we can talk about is the adjacent side. Remember, the word adjacent means next to. Okay? So which side is next to A? Well, the adjacent side would be AB. That's the side that's adjacent. Our other side, our last side, is the hypotenuse, which is the longest side. So AC is our hypotenuse. Now some people say, well, why can't AC be the adjacent side if we're looking at angle A? And I always say, yes, it is adjacent to angle A, but it can't be the adjacent side because it's the hypotenuse. Okay? Alright, so sine of the angle equals, now if you look at these, OH, AH, OA, they stand for opposite hypotenuse, adjacent hypotenuse, opposite adjacent. And what they mean is that sine of whatever angle we're taking, sine of that angle is the opposite side over the hypotenuse. Okay? So if I'm going to take the sine of angle A, okay, the sine of angle A, it's going to equal the opposite side over the hypotenuse. Okay, in this case, we said the opposite side from angle A is BC. And the hypotenuse is AC. So the sine of angle A is BC over AC. Okay, so let's put some numbers in here. Right. Now if I wanted to find the sine of angle A, sine is opposite over hypotenuse. So the sine of angle A would be 4 over the hypotenuse, which is 5. 4 over 5. Okay? Now let's look if we were going to take the cosine of angle A. If I was taking the cosine of angle A, well, we have to look and see cosine is the adjacent side over the hypotenuse. Okay? So the adjacent over the hypotenuse. When I look at angle A, which side is adjacent to angle A? Well, AB is the adjacent side to angle A. So AB over the hypotenuse, which is still AC. Okay? So if we were to put the numbers in, cosine of angle A is the adjacent side, which is 3, over the hypotenuse, which is 5. Alright? If I was to take the sine of angle C, I have to look. Sine is opposite over hypotenuse. So looking at angle C, I've got the opposite side is 3 over the hypotenuse, which is 5. If I was going to take the cosine of angle C, I look over here and see that cosine is adjacent over hypotenuse. So looking at angle C, the adjacent side is 4 over the hypotenuse, which is 5. Okay? Alright. If I want, well, sine and cosine are covered in lesson 7.6. Okay? The tangent function is covered in 7.5. So at the end, I'll do all of our tangent stuff. Alright? Okay, so sine and cosine. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. The other, this is the saying that I always use. The other one is called SOHCAHTOA. Okay? And you can probably look and see what that stands for. It stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? You can use either one that you want. I don't care. They both work the same. Okay? I always tend to use that one because that's what I was taught when I was younger. All right? So let's look at an example. Might help us make more sense of it. Okay, so let's draw a triangle. Say that angle is 35 degrees. This side is 11. And we want to find x. Right? So, what we're going to do in a case like this, we're going to look and see what angle they give us. And in this case, they give us angle 35. And we're going to figure out which two sides do I have out of the adjacent side, hypotenuse, and the opposite side. Which of those two, which two out of those three do we have? All right? So looking at 35, we've got 11 and we've got x. This side is the opposite side in relationship to the angle, okay? Because it's on the opposite side. All right? And then x is the hypotenuse. So if I have the opposite side and the hypotenuse, I have to look up here and see which of these am I going to use if I have the opposite and the hypotenuse. And I would see I'm going to use sine because sine is opposite over hypotenuse. All right? So that tells me I'm going to use sine, so I'll write down sine. All right? Then what comes next? We talked about it up here. The next thing we put is the angle. In this case, we know the measure of the angle. So I'm going to say sine of 35. Okay. And that's going to be equal to, we know that sine stands for opposite over hypotenuse. So our opposite side is 11 over the hypotenuse, which is x. And we have that equation right there. Okay? Now, let's go over here and I want to show you something really quick. If I was to make this look like a proportion, like so, remember we've talked about the different properties of a proportion and how you can flip these and it still works. You can interchange diagonally and it still works. So we're going to do a little shortcut. We're going to use, we're going to interchange sine of 35 and we're going to interchange x diagonally. Okay? Now you might be thinking, why would we want to do that? Well, the reason that we would want to do that is because x is in the denominator. And when x is in the denominator, we're going to have to do a few steps to get it out of the denominator. Okay? If we do this, take this shortcut, we can get it out of the denominator in one step. Right? We know that we can interchange diagonally. We've talked about that before. So then, our proportion looks like this. X over 1 equals 11 over sine 35. Right? So we can interchange these two. Now we have x over 1, and we don't need that 1 anymore. So really what we have is x equals 11 over sine of 35. Okay? Now we have x all by itself. And all you need is a calculator. Okay? If you have a graphing calculator, like this one, you need to make sure that your calculator is in degree mode. And the way that we do that is we press the mode button right there. Okay? Then you're going to go down twice and to the right once and press enter. And you'll see it says degree on there. And you need to make sure that the degree is highlighted. If you have a calculator like this, right, that button changes it. Okay? And you can look right down here, look and see, mine is in degree mode and it says DEG right there. That means it's in degree. If it doesn't say degrees, if it doesn't say DEG, then you need to make sure you press this button and look right there and make sure it's in degree mode. Okay? Alright, so we've got x equals 11 over the sine of 35. So we need to put that in our calculator. Okay. We're going to say 11 divided by sine of 35. Enter. If we wanted to round that to one decimal place, we would see that x equals 19.2. Right? So x equals 19.2. And that would be our answer. Okay? Now, because we're using a calculator to find our answer, we need to always make sure that this answer makes sense. Okay? In this case, it does. But what if we would have gotten x equals 10.2? Right? If we got x equals 10.2, we should see, wait, that's smaller than 11. That can't be right. Right? So always check to make sure that your answer even makes sense. Okay, let's try another one. Let's scoot down. Let's draw another triangle. Say this angle is 28 degrees. It's 32. And we want to find x. Alright? So, we've got this angle right here, 28. And remember, excuse me, the first thing that we need to do is figure out, alright, do I have the opposite side, the adjacent side, the hypotenuse? Which of those two sides, which two out of those three do I have? Okay? Well, x would be the adjacent side to our angle. Okay? And 32 would be our hypotenuse. So if I have the adjacent side and the hypotenuse, I'm going to use cosine. All right? So that tells me already I'm going to use cosine. And remember, what goes next after cosine? We always put our angle next. Okay? So we've got cosine of 28, because that's our angle, equals, now cosine, remember, is adjacent over hypotenuse. So which side is the adjacent side? X is our adjacent side over the hypotenuse, which is 32. Right? Now, in this case, it's not like up here where x was in the denominator. So we don't have to use our shortcut here. In this case, we just need to get rid of the 32. So the way that we get rid of the 32 is we just multiply both sides by 32. Because then those 32's will cancel out, and we will get 32 times cosine of 28 equals x. Right. Now, all we have to do is put that in our calculator. 32 cosine 28. Press enter. And if we wanted to round that to one decimal place, we would say 28.3. So we find that x is 28.3. Right. Now, again, we got to look. Does that make sense? Could that be 28.3? Absolutely. It does. If it was bigger than 32, then we would have a problem. Right? But that's how we find x. Okay? Alright, we need to talk about two other things, two definitions. Okay? The first one is called the angle of elevation. And the next one is called the angle of depression. Right? Angle of elevation. When you hear that word elevation, or when you elevate, that means we go up. Right? So, what an angle of elevation is. Okay? We've got our guy here. And we're going to look at his horizontal line of sight. If he was looking exactly parallel with the ground, exactly horizontal, okay, that would be his line of sight, the dotted line. If he were to tilt his head up and look up, like so, okay, look up, that would be an angle of elevation. That right there is our angle of elevation. Right? The angle of elevation is the angle that is made by the horizontal line of sight and your actual line of sight if you're looking up. Okay? Angle of depression. Right? Depression, when you're feeling depressed, you're feeling down. Okay? So if we have our horizontal line of sight, our angle of depression would be the angle if we were looking down at an angle like so. Okay? So this angle right here would be our angle of depression. Okay? Alright, so we're going to look at this word problem. Okay? It says you are skiing down a mountain. Okay? With an angle of depression of 21 degrees. All right. You are at an altitude of 1,200 meters. Okay. How far must you ski to reach the base of the mountain? Okay, so let's draw us a little picture. So here's the mountain, there's the base of the mountain. Right, here you are. There's your skis, there's your ski poles, wearing a beanie, you're skiing. Right? Now, let's look and see what we know by what the problem's telling us. First thing that we know is that the angle of depression is 21 degrees. Okay? So let's figure out where that angle is. If this is my horizontal line of sight, okay? Remember, angle of depression means when we're going down. So this angle right here is our angle of depression, and it's 21 degrees. Right? That's our angle of depression, just like up there. Okay. Another thing that we know is it says that we are at an altitude of 1,200 meters. So that's how high we are. So this distance right here is 1,200 meters. And if we look, we just made ourselves a nice little right triangle. It says, how far must you ski to reach the base of the mountain? So we're looking for this distance right here. We're going to call that x. Right? So there's our triangle, and we're trying to find x. Alright? So, let's look at our angle, and the first thing we need to do is figure out which two sides do we have. Do we have the hypotenuse, the opposite, or the adjacent side? Okay? We're looking at 1,200, it's on the opposite side of our angle. So we have the opposite side, and x is the hypotenuse. So if we have the opposite and the hypotenuse, we're going to use sine, because sine is opposite over hypotenuse. Okay? So, we know that we're using sine. And we know that after sine or any trig function, next we put the measure of the angle. Okay? So sine of 21. And we know that sine is opposite over hypotenuse. So our opposite side is 1,200. And our hypotenuse is x. Okay? Now, this one looks very familiar to the one we did up here. When x is in the denominator, remember we're going to use our little interchange shortcut. Alright? So since x is down here in the denominator, we're going to exchange these two. And that's going to give us x equals 1200 over sine of 21. Alright? So we take our calculator and say 1200 divided by sine of 21. Enter. And we should get 3,348.5. So x equals 3,348.5, and we're talking about meters. Alright? Okay. That problem right there is a typical ACT, SAT question that you'll have. Okay? Draw your picture, set up your triangle, we'll use sine, cosine, or let's use tangent now since we haven't used tangent. Right. Like I said, tangent is covered in section 7.5. Okay? So let's look at it really quick. Let's say we've got this triangle. We've got this right triangle. So that's 10, that's 8, and that's 6. Right. Let's draw our Oscar had a heap of apples. Sine, cosine, tangent. Alright? So, tangent is opposite over adjacent. So if I wanted the tangent of, let's say we're going to look at angle C. Okay. The tangent of angle C would be the opposite side, which is 6, over the adjacent side, which is 8. Okay. And then when we simplify, we would get that equals 3 over 4. If I wanted the tangent of angle A, looking at angle A, the opposite side is 8. The adjacent side would be 6. Okay? Opposite over adjacent. When we simplify, we would get 4 over 3. Okay? Alright, let's do an example. Tangent really quick. Okay, so that angle is 32 degrees. Here's x, that's 11. Right? So, look at our angle. Let's figure out which two sides we have. Right? We've got the opposite side and we have the adjacent side. Okay. Opposite over adjacent, that means we're going to use tangent. Okay. So tangent. Next we put our angle, tangent of 32 degrees, and that equals opposite over adjacent, 11 over x. All right. Again, look, we have x in the denominator, so we're going to use our little shortcut. We're going to interchange tangent of 32 and x. Right, so that's going to give us x equals 11 over tangent of 32. Okay. So we have that. We're going to take our calculator and put that in our calculator. 11 divided by tangent of 32. Press enter and we get 17.6. Okay. Equals 17.6. Alright. Okay. So we talked about sine, cosine, and tangent. You need to remember one of these two sayings. Either Oscar had a heap of apples, or you need to remember SOHCAHTOA. Alright? Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Alright, you can find your homework on RenWeb.